Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast, brought to you today by the Precision Metal Forming Association and the PMA's Educational Foundation. I have with me today, and it is my distinct pleasure to have Dr. Amy Elliott, who is a research scientist over at Oak Ridge National Lab. She is one of the mover and shakers of everything that's going to be happening in our future. Welcome, Amy.
Hi, how's it going?
It's excellent. It's excellent. And I really do appreciate you being on here today. I had the opportunity to hear Amy speak about a year ago almost, coming up at Manufacturing Day, and it was amazing. So everybody is in for a treat today to hear your insight into the destiny of manufacturing.
Thank you.
So tell us a little bit about yourself and everything you have going on, which is extensive.
Right, yeah. So, I'm a scientist at Oak Ridge National Lab, and I work at the Manufacturing Demonstration Facility. And so at the MDF, we research additive manufacturing, which is just a fancy word for 3D printing. So it's a pretty fun job. I get to play with 3D printers all day. Well, I wish it was that way, but pretty close. So the unique thing about the MDF is that we have so many different 3D printing technologies. Most people don't know that, but there's actually 7 different, we'll call them species of additive manufacturing or 3D printing technologies, and we have several of those. And so we have a lot of problems to solve, a lot of issues with 3D printing right now, but it's an exciting field to be in, and I'm just really, really happy to be where I am.
Well, it is an amazing field, and it's an unbelievable time to be in it. It's taken off at an unbelievable trajectory, and it is advancing at warp speed.
Absolutely. I like to compare it to how, when the PC first came out, or when computers first came out. When they were first out there, they were big, bulky. They didn't really do much. They're very, it took specialists to operate them. They could, have limited capabilities, and then over time they evolved. And the first PC was a kit, right? You put it together yourself. Same thing with 3D printers. There's kits, these hobbyist kits you put together. And then once they became more, commercial, and the average person could use it, there was so many different variations. And right now you can see out in the market, you just Google, 3D printer. There's just, dozens of different companies selling these, different iterations of these desktop 3D plastic printers. And so, we're still in that place where, companies are still going for that land grab, and there's just a huge variety of approaches. But I think eventually we'll see a convergence into, these mainstream designs and these mainstream products that can be used by the average consumer. But until then, we're still kind of something that nerds do in their basement, right? 3D print at home. And then also things that, scientists are working really hard on to develop.
Sure. Speaking of that, what is your opinion on open source versus closed source, the benefits of those? For those that don't know, a lot of the softwares and a lot of the machine codes for 3D printing is either a closed system where everything's kind of defined by that company, or open source where there's a lot of file sharing going on back and forth. So what I was asking is, what is your opinion and benefits of either or both of those?
Yeah, absolutely. Typically when we refer to open source versus closed source, it's how much control you have over the machine. So an open source machine would let you pretty much change anything about it. So the company has just, given you full control, full access to everything, and you can do whatever you want. So the advantage of that is, the freedom you get, but the disadvantage is if you don't know what you're doing, you can definitely cause some damage to the printer itself. So, sometimes these are expensive machines. Some of them have lasers on them. Some of them weld metal powder, which is very dangerous. And so, the advantage of, a closed source or, pseudo closed source system would be obviously the protection. The company has found those limitations for you, and you have to repeat their mistakes. But then the advantage of the closed source would be, hey, here's kind of your playing field. You're not going to get hurt in this space, and you can do some R&D in this space. So the disadvantage of closed source would be obviously that, if you're not a beginner, you probably want to crack the code a little bit, do a little bit of hacking, and make it do something that a company hasn't figured out yet. So there's pluses and minuses to each of them. I'd say for a beginner, you definitely want to get that closed source system and work within the boundaries. But as you get more advanced in your experience, then the open source is definitely direction you want to head toward.
Yeah, that's a great way of putting it, because for a lot of people that struggle with some of these open source systems, it is a steep learning curve for a lot of the systems, whereas the closed systems tend to become kind of an out-of-the-box system, and it's ready to go. It may have limitations, but there's no question it can get up and running a little bit faster than some of these open systems.
Yeah, absolutely. And if you're a tinkerer, you don't mind the hustle of fixing your open source printer and troubleshooting, then it can be fun to get an open source printer for really cheap and get it running. But I guess for me, I'm at the point where it's like, okay, I've learned what I'm going to learn. I don't want to solder on, or I don't want to hook up another printhead. I don't want to replace another printhead this weekend. I'd rather print something. So
Right.
I'm actually just selling all of my junker open source kit printers and just replacing it with a nice closed source one that will just print for me, actually.
Sure. I understand that. So obviously the name of the show is The Destiny of Manufacturing, and what I'd like to do is I'd like to get your opinion of what you think, let's say 5 years into the future or so, what you think will be happening in the world, and where will we be with that space of additive manufacturing?
Yeah, absolutely. So I guess to talk about 5 years from now, I might need to just talk about where we are at this current moment. Right now we're working toward identifying applications where additive makes sense. So right now additive is expensive and it takes a long time. So you really have to identify those key high value applications where you get your return on investment when you do with additive. So I think in 5 years, the cost is definitely, it's going to go down. So additive's going to be cheaper, and that means it's going to be available to some lower value markets. So I don't know that we'll be in automotive manufacturing making these parts to go on cars just yet in 5 years, but we'll be making a lot more jigs, a lot more fixtures, and then tooling. Tooling is really kind of the sleeping giant in additive right now. We like to say at the MDF that the top 3 applications for additive are tooling, right? So tools are They are high value, they are low volume, and they're high complexity, and they usually have really long lead times. And additive as a technology is actually able to improve on all of those things. So instead of waiting on a bill of material to make your tool, you have some lead time associated with that, depending on how big it is. You always have the quote unquote billet ready. With additive, you always have the same feedstock size, whether it's powder, wire, sheets, whatever. You always are ready to make whatever size part you need, as long as the printer can obviously accommodate that. So we're going to see a lot more takeover of the tooling industry with additive. I think in the next 5 years, that's going to be the big wave in adoption. Is the tooling industry.
Right. And I think from the audience of that we have is a lot of Precision Metal Forming Association users. So it's a lot of people in stamping, and that's a huge area that people are looking to improve on and take advantage of at this time. So I think you're speaking to exactly what they're looking for an outcome over the next few years, is will there be more opportunity in the tooling? And I think you hit it right on the head that there will be. And
Yeah, absolutely. And you mentioned stamping, and that's it's very interesting because stamping tools are expensive, right? They're usually pretty big. They're made out of really hard materials. Yeah, so they're just expensive. Some of them you do need cooling channels inside, so you'd have to figure out how to make this thing in parts and drill holes throughout, or it can get complicated. And so I think a lot of people don't realize that additive is moving towards making those much cheaper, higher performance, conformal cooling with no added cost. With our large metal band technology. So I think once the word gets out and we get more and more of these demonstrations, people are going to start to start adopting just very fast, very quickly.
right. Speaking of BAM, can you explain for those who aren't familiar with that what that type of manufacturing is considered?
Yeah. So when we say BAM, it's kind of an industry jargon, but it stands for Big Area Additive Manufacturing. So BAAM, and basically it just refers to any additive manufacturing or 3D printing technology that's bigger than the normal size machine. So we started out with the plastic BAM technology, which is a huge printer, 20 feet long, 8 foot tall, 8 foot wide, in the build area, and then the machine itself is obviously bigger than that. And 4-inch nozzle can put down 100 pounds an hour, and it just prints really large things very quickly. And so we call it the plastic BAM. So we started on that about maybe four years ago, and since have transitioned to researching on metal BAM, which is welding technology, but in an additive technique. So basically just building parts by adding layers of weld over and over again. So not as easy as it sounds. So there's a lot of research to be done, but we have shown that you can build some really large metal objects with internal features like cooling channels fairly easily. So I think it's going to be a big deal when companies start getting wind of this technology, especially those stamp tool makers.
Is that an area that you think that there will be more opportunity to, instead of having to move things from one location to another, you'll have the opportunity to just print them on site? Is there a bigger advantage to that?
Yeah, so that's a good question, and it kind of goes to this larger argument and vision for additive is that once we nail the process settings, once we nail those down, once we get the machine smart enough, we give the machines enough intelligence to understand still failures or what success looks like, that kind of thing. You then have this tool that you can put basically anywhere with maybe a skilled operator, maybe not, and produce things that are typically produced in specialty shops, right? So instead of me ordering a tool from another country, in which we normally do, I could just order this machine that can make any tool that I want, right? So I think it definitely minimizes the amount of equipment that is required to make things, and it replaces normally specialty equipment with one tool basically. So there's a lot of arguments for going in the direction of additive, especially when you talk about you have multi-level tier suppliers, especially in the automotive industry. You can cut some of those tiers out by producing in house or close by.
Right. Is there progress being made in the areas of speed that you've seen? Anything making, I guess, very large jumps in any of the technology speed-wise?
Yeah. So for the plastic BAM, there's definitely a step change in the speed once we went to the larger nozzles. So normal plastic extrusion additive manufacturing uses very small nozzles, like talking about 0.5 millimeter in diameter, and so there's only so much plastic you can push through a nozzle that size, right? So the the positive part of having small nozzles, obviously the resolution. So we go into a 1/4 inch nozzle, one that's 1/4 inch in diameter. You push through a lot more material. And so we went from doing 1 to 4 cubic inches an hour to like 1,000 cubic inches an hour overnight, just by changing the nozzle diameter. And so, but we do obviously sacrifice resolution. So, but yeah, so we've definitely seen this speed increase in terms of those systems. But for the metal systems, it's still a challenge. The metal printers are typically very slow. If you're talking about laser or electron beam, laser more so, but it can take several days to make a small part. And you're talking about $1 million machine. The cost scenario is not really going to be there for every industry, and so that is a challenge that we're working towards. How do we make that next step change in metals, just like we did with the plastic? So it's a challenge.
Right. Do you anticipate additive in its next iteration moving forward? Do you envision it more being where actual manufacturers are using this in-house, or that they might go to a regional supplier who is actually printing for, a city or something like that, where rather than trying to take that technology on because they don't have the staff, they don't have the training, and it's a steeper learning curve. Is there a value to making that interim step there before they take it in-house?
Yeah, we're already seeing this right now, where there's a lot of these job shops starting up centered around just additive technology. So, and that's what I always recommend people that we talk to is, go to these service providers. They have these machines, they run them every day.
Right.
Order some parts from them, walk through the process with them, get to know it before you make a large investment in a machine on your own, because there is a pretty steep learning curve, especially right now. And so, yeah, I think in the near future, that's definitely what it's going to be. I think there'll be these service providers that'll just be, selling parts to companies. But eventually, depending on the business structure of the company, they might want to invest in their own production capability. I think we see that with GE. They're buying out a lot of these additive manufacturing companies and developing the technology on their own for their own specific applications. So they have some unique materials they want to process, unique geometries, and so they're taking that in-house for their strategies. But it just depends, right? Not everyone's going to take that strategy, and so yeah, it just depends.
Yeah, I think you're right. I think the size of the company definitely matters, because a company the size of GE may say, yeah, we can take that in-house and we can develop specific to our needs, as opposed to somebody who's maybe very limited and only wanting to explore it from the standpoint of tooling, and they may be only needing 5, 10, 20 tools a year. It may not pay for itself to bring in that technology.
Yeah, absolutely.
Now, let me ask you a question about technologies that we may not look at or may not typically think of in the additive realm. Things like food industry, things like clothing. I know that last year at the Rapid Show, they've had a fashion show actually at the event. What is your thoughts on that, of where that's going?
Absolutely, yeah. So I personally have 3D printed shoes. There's a company called Beep that prints custom shoes, and they're super comfy. I've had them for 2 years now, and they're just great. I love them. I have 3D printed jewelry. I print things for my house all the time, and so I see a future where you walk into your closet and you put on these clothes that are printed just for you, and you take a 3D scan of your body and you send it to a designer and they email you back some design files, and your printer in your closet prints them for you, and you can put in your old clothes and it recycles them. And I can definitely see a future like that, especially since the consumer market is moving towards more and more custom things, custom clothing, custom jewelry, custom products. So I'm excited about that. I think that's going to be really neat. I hate shopping. I think it's going to really, really help with that.
Well, I think that's really interesting, though, that you have the option of something that's customized just to you and produced just for you and your tastes. I think that really adds to people's creativity, and rather than just having something that everybody else has, you can make what just you want. That's pretty interesting.
Yeah.
Now, what about on the food service industries and things like that? I know that they've done some things with chocolate and some other things where they're actually 3D printing those.
Yeah, absolutely. It's kind of interesting. Some of the things they're doing on the food side. I'm not sure that there's like a big application for it. So, but like maybe something will come up. But yeah, I know they've extruded like protein or like pureed meat or something. I don't know, and trying to make a steak or yeah, I think there's definitely going to be some food applications. I can envision a future where you have some printer in your kitchen that has all these different cartridges in it, and they're in the refrigerator, and you order like muffins for breakfast, and you push a button and the muffin the printer grabs the muffin cartridge and extrudes it into a cup or something, or prints a cup and extrudes into that and then bakes it, that kind of thing. I can definitely envision a future where that's possible. Yeah, I just don't know what the consumer push is for that. I don't know if we're that lazy yet.
Well, I know that you had made mention before at one of your presentations, you were talking about people with special needs, like somebody who was a diabetic, that you could custom tailor the food. Tell us a little bit about what your thoughts are on that. I know it's not specifically here today, but what your thoughts are on that process in the future.
Yeah, absolutely. So just I don't want to take credit for something that's not my idea. This is from Hot Lips and Foot Fabricated. But they envision a future where if you have diabetes, you have a sensor in your under skin that can send your blood sugar level to your food printer. And when you wake up in the morning, you pick what you want for breakfast, and the food printer, adjust the recipes to accommodate for what your biosigns are. So people with maybe hormonal issues, or I don't know, anyway, so I don't want to get too detailed into that, but people with chemical imbalances in their system definitely benefit from maybe the printer can adjust their medication and put that into their food or something. So definitely thinking about integrating health into 3D printing in terms of these food printers with these little cartridges that can print whatever you want and do it.
Right. Well, I tell you what, the future of the Jetsons isn't as far off as we might have thought. So.
Yeah, I think so. As we get farther machines, we get better interior properties, we get tastier food. You can imagine machines everywhere. And the 3D printers on the machine, on different machines. I think of the movie Passengers, where the starship, was hit by a meteor and it repaired itself. Like maybe we start building vehicles or different things so that they can break or be damaged. We can build them cheaper and more efficiently because they can repair themselves. Incorporate that into repairing technology too. So yeah, I think there's a lot of different opportunities. future's gonna be cool. It's gonna be amazing.
Well, I hope it happens sooner than later. Let me put it that way.
Absolutely.
Uh, tell me about what you think are some of the challenges that we're going to be facing in additive here in the near future.
Yeah, absolutely. The big challenge right now is material property. So when manufacturers use products like parts of machines, tools, there are standards associated with that, obviously, and those standards have to do with the chemistry of the metal, what alloy are you using, and then also what microstructure do you have, like which gives you your properties, and the standards that industry knows and uses and trusts. They're all based on processes that are not additive manufacturing, that have
Right.
no resemblance to that process. I mean, for the metals, in a lot of cases with welding, welding layers of powder together, there's really kind of no analogy for that in traditional manufacturing. And so we're facing this chicken and the egg scenario. Is like, well, do we try to match the standards, try to match our microstructures to these other processes, or do we try to make new standards on our own and go that route? So that's one of the challenges that we're facing. And then another challenge is just quality control. So some of these systems have a lot of variation just because we're still learning about the technology itself. And so, how to build these machines, make them repeatable, how to make the process more consistent. And so quality control is a big deal. So can we integrate machine learning, artificial intelligence, vision systems to recognize, variation in the process and then help us characterize the process to make it better. But then also be able to do this, quote unquote, born qualified printing where, I'm watching the whole print and I have so much data about this part that I can guarantee you that this part's going to perform, this way. And getting into a level of data analytics that we've never seen before in production. Right. So there's going to be a lot of data to handle and to be able and to have to interpret. But yeah, those are the major challenges right now is the material properties and the quality control.
Does that also include things like the material strengths too, using compounds so that we can get a balance of flexibility as well as strength?
Yeah, absolutely. And just trying to match those properties to the existing alloys that are certified. Absolutely.
Right. Amy, tell me a little bit about your background, and I don't know if everybody knows this, but your history on TV shows.
Yeah, absolutely. So when I was in grad school at Virginia Tech, there was this casting call by the Discovery Channel that went around for a show called Top Engineer. All right, they were looking for engineers with hands-on experience. So they were going to do competition reality show, and so I had done Baja SAE and NASA Moon Buggy, and I apprenticed a machinist, and so I had fabrication skills. I could weld, I could machine, I could find my way around the shop pretty well, and so I applied and I made the show. So I was on this. They ended up changing the name to Big Brain Theory was the name of the show, and so I was on this reality show. Went out to film in LA for several weeks, and ended up getting second place, which was not perfect, but
That's great,
when I got second place, I did get some condolences from Buzz Aldrin himself. He took me by the shoulders and he said, "I knew what it's like to live in the shadow of another," which was just awesome. Buzz Aldrin equated me to himself, so super special. So I'd take second place any day for that. But so yes, that was a really fun yet stressful yet crazy experience on that reality show. And since then, I've got a few other gigs. I'm on Science Channel right now on a show called Outrageous Acts of Science. I've been on, I think, about 6 seasons so far. And so I go out to LA, film for that about 4 times a year. And then I'm also on a web series called Robo Nation TV. And we host these different collegiate and high school middle school robotics competitions that have to do with autonomous water robotics, and so that's really fun too. So yeah, I moonlight as I guess kind of a TV personality, on camera STEM producer. So it's pretty fun. I would have never imagined I would have that kind of opportunity and exposure in my career, but it's been great.
Well, I think that's it. It really shows people that there are other opportunities just within this field of science, technology, and it gives some hope to some people that might have an interest in that, and show that there is some outcomes that you can have that you might not have expected. So,
absolutely.
Well, I think we're just about out of time, and I really do appreciate it, Amy. It's always a pleasure to have you on our show. You've done a phenomenal job with Oak Ridge National Labs, and I know that everybody there can't say enough good things about all your hard work. So I'd like to thank you again for being on the show. And again, this is the Destiny of Manufacturing podcast, brought to you today by the Precision Metal Forming Association and the PMA's Educational Foundation. Thank you, everybody. I've been your host, Dean Phillips, and I want to thank everybody out there for taking their time to listen to this show today. Have a great day.